Welcome to the video on complex numbers. Our outcomes today deal with adding, subtracting, multiplying, dividing complex numbers, and then also playing a little bit with powers of complex numbers. To begin with, let's look again to see where complex numbers fit in the scheme of all number systems. The numbers that we deal on a daily basis typically are integers. Sometimes we deal with fractions or decimals. But rational numbers combined with irrational form the real number system. And that's where most of us live all of the time. Those are the numbers we deal with. Complex numbers include both real numbers and imaginary numbers. Now let me give you an example of an imaginary number. In the past, in other math courses, you will have dealt with quadratic functions. And here's a picture of a quadratic function. This one right here. So this quadratic function has as zeros, or often we say as the answers, or x-intercepts are other answers for that. It has as its zeros -3 and a +2. Those are the places where it crosses the x-axis. And those x-intercepts, in certain cases, give us some valuable information. Those zeros are valuable. These numbers are real numbers because they cross the x-axis at distinct real number places. They could cross in between there too. Those are still real numbers. If, on the other hand, I have a graph of, again, a quadratic function which does not cross the x-intercept, I still want to talk about zeros. They can't be real zeros because they're not crossing here, and so we call them complex, or some people like calling them imaginary zeros. And so to deal with these, we want to be able to know what a complex number is, how to deal with complex numbers, and then how to add, subtract, multiply, divide. So first off, here's a definition of complex numbers. So a complex number is one in which can be written in the form of a plus bi, where a and b are real numbers, and the a is the real part, and the b, or the bi, is the imaginary part. Now we throw this I in. What in the world is I? Well, here's how mathematicians define I. So they call it a number, and they define I as being the square root of a -1. In past courses, whenever you came up with this, people probably told you to stop, or you can't take the square root of a negative number. And in the real numbers, that's certainly true. But it is actually the definition of a complex number. So the square root of -1 is equal to this imaginary number I. So anytime I see the square root of -1, I can replace it with an I. Or, if I want to revise that a little bit, if I square both sides like this, square this side, I get rid of the square root sign and left with -1. I square this side and I'm left with I squared. So if I square both sides, then I come up with two sort of swaps or two substitutions that I can use. Here's one. Anytime I see the square root of -1, I can replace it with an I. Or vice versa, if I see an I can go back to a square root of -1. And also, if ever I see an I squared, I can replace that with -1. And those tools will help us a little bit when we're adding, subtracting, multiplying, dividing. Here's just a quick little example of working with that square root of -1. So, if I come to my answer and it says the answer is the square root of -4, I recognize it as being a non-real number. It must be a complex number. So I can simplify this, realizing that I know that I squared is equal to -1, or the square root of -1 is equal to I. Those are my two swaps that I can do. I recognize square root of -4 as the same thing as the square root of -1 times the square root of 4. That's a basic radical rule that you can do. Anytime you have two things that multiply together to give you, or two factors of a number, I can split that up. So the square root of negative 1 times the square root of negative 4, that's the square root of negative 4. Now, the square root of negative 1, we just learned, is the same thing as I. And of course, the square root of 4 is 2. So to simplify this, I could just simply call it I times 2, or typically we write it as 2I. Here's another example. There's a couple of negatives here. Let's forget that negative out front just for a minute. But let's rewrite the square root of negative 12 as the product of the square root of negative 1 times the square root of, I can multiply 3 and 4, so square root of 3 times the square root of 4. Okay, this is the same as what I started with. So this is equal to negative. Square root of negative 1 is an I. Square root of 3, can't do anything with that. But the square root of 4 is 2. So I can simplify this, and writing it in sort of its proper order would be negative 2 root 3 I. Sometimes people put the I in front there, and that's okay too. Typically it's written at the end, but you can put it in there. Be careful not to extend this vinculum, or not vinculum, this radical sign. Careful not to extend that too far over the I. Okay, so we've got a definition of complex numbers. We know how a little bit to work with them. So let's jump in and try some adding, subtracting, multiplying, and dividing. So adding and subtracting complex numbers. So one important part to think about if you're adding and subtracting complex numbers is that the I part of any complex number can be treated, if I'm adding and subtracting, or if I'm multiplying and dividing, I can treat it just like a normal variable. So if I'm wanting to add these, I just look for like terms. I'll drop the brackets, 2 plus 5i plus 8 minus 3i. Look for like terms. 2 plus 8 is a 10. 5i minus 3i is a minus 2i. So I treat those i's just as I would an x or a y, a different variable. And so this would be my answer to that simplification. Now, notice that I've written I as the second part of this. This is the same thing as minus 2i plus 10, but this is the preferred form of writing it. Okay, here's another example. Notice here, trying to mess you up with that negative sign in front of a bracket. Let's first get rid of the brackets. So I need to apply that negative sign throughout the bracket. So it become not minus 8 and a positive 3i. And then after that, it's simply collecting. 2 take away 8 then is negative 6. 5 plus 3 is a positive 8i. So adding and subtracting complex numbers with the i's, you just have to treat those as you would any other variable. Alright, let's jump into multiplying complex numbers. The one rule that I can't emphasize enough is that if I'm multiplying complex numbers, and both these are complex because it's a square root of a negative, is you first want to get rid of the radical. So lose the radical, convert that into the I form. So get it into the I form first, then do your multiplication. Okay, so make sure if you see radicals with a negative radicand, you first convert those. When you multiply these two, if we were doing it the old way, where I just have to multiply the radicands together, you'd come up with a positive 20, or the square root of a positive 20. But if you convert first, watch what happens. The square root of negative 2 is the same thing as 2i, and the square root of negative 10 is the same thing as this. Well, this is root 2i, and this one will be root 10i. So now when I multiply those two things, I get the square root of 20 again, but then I times I is I squared. Or I squared, remember, is the same thing as negative 1. So it'll be the root 20 times I squared is root 20 times negative 1, which is negative root 20. So notice the difference between this one and this one. This is correct to convert it to the I form first. If you're just multiplying the radicands, if they're negative, this is incorrect. So let's try one. Here's one. Oh, it's a FOIL thing. No, we can do that. FOIL with the radical things. Before I get off going my 2 times 3, 2 times this, let's first convert these radicals to the I form. So I'll rewrite it as 2 take away root 7I. Okay, there's 1, and the last one will be 3 plus root 7I. Okay, so to do my FOIL thing, 2 times 3 is 6, 2 times root 7I will be, oh, this will be awkward, 2 root 7I, and then minus root 7I times 3 will be a negative 3 root 7I. And finally, negative root 7I times positive root 7I will be a negative root 49I squared. Now watch what happens when I simplify this. I get 6. 2 root 7I minus 3 root 7I would be a minus 1 root 7I. I can do that because they're common, they're like terms. But here, the square root of 49 is 7, so this will be minus 7. Oh, but I squared is equal to negative 1. So I can rewrite this again. 6 take away root 7I. This will be plus 7. And now I've got like terms here, so the final answer, this one, will be 7 plus 6 is 13 minus root 7I. A little bit of multiplication in there. Key thing, anytime I've got a negative radicand, convert that to the I form first, then go ahead and multiply. Division. Division of conjugates, and I guess simplifying of fractions or division where I have a complex number on the bottom. You deal with those similar to you would deal with fractions that aren't simplified. Or I guess that's the idea that you want to think about. Is like if I have a square root in the denominator, like this, square root of 2, I know that's not simplified. It sticks out like a sore thumb, sort of like 4 over 8. If I look at 4 over 8, I say, oh, that's not simplified. I have to change that to 1/2. If I see a radical on the bottom, it's, oh, I've got to multiply both top and bottom by that radical in order to get it so that there's not a radical on the bottom anymore. Same thing when you have an I on the bottom. So just as 4/8 just sticks out like a sore thumb, if I have something like 2 over I, it's, oh, that I on the bottom, I have to simplify. I have to do something with that. Or something like x over 3 minus I. Again, an I on the bottom indicates it's not simplified. I've got to do something with it. So here's an example, a couple examples. So if I see 5 divided by 3i, I can't simplify the 5 and the 3, but this I sticks out. So what I need to do is multiply both the top and the bottom by the conjugate. In this case here, I simply need to multiply the bottom by 3i and the top by 3i. So on the top it becomes 15i, and on the bottom 3i times 3i is 9i squared. So simplifying on the bottom, I have 15i, I squared is negative 1, so this is negative 9 on the bottom. And I can simplify the numbers by dividing top and bottom by 3, giving me 5i over negative 3. And that would be the simplification of that. Now here's another example of dividing where I've got a binomial on the bottom. If I have a binomial, I need to multiply again by its conjugate. So the conjugate of 1 minus I will be 1 plus I. So I need to multiply both top and bottom by 1 plus I. So on the top, that gives me 14 plus 14i. On the bottom, notice it's a difference of squares. So 1 times 1 is 1. 1 times I is plus I. Minus I times I is minus I, so those cancel. So on the bottom I just have to go minus I times I is a minus I squared. On the top I have 14 plus 14I. On the bottom, I squared is the same thing as negative 1, and 1 plus 1 is 2. So in this case I get 14 plus 14I all over 2. Oh, I can simplify further. 2 will go into both of those. So I have 7 plus 7I. That would be the final simplification of the first one. Okay, so if I see an I on the bottom, ouch, I've got to do something with that. If it's a binomial, multiply it by its conjugate. If it's a monomial, as in this example, simply multiply it by itself, 3I. I guess you could multiply it by I as well. That would work. Final concept of things with complex numbers is dealing with the powers of complex numbers. And just watch the pattern that happens here. What we're wanting to work towards is solving a question like I to the 21st. You know, what does that equal to? If we do this, we can look for some patterns. I squared, we know that's minus 1. But I cubed is the same thing as I squared times I. So if I squared is minus 1, I cubed must be just negative I. Watch the pattern. Negative 1, negative I to the 4th is the same thing as I squared times I squared. I squared is negative 1, so negative 1 times negative 1 is equal to a positive 1. Any pattern yet? Yeah, maybe. I to the 5th is the same thing as I to the 4th times I. I to the 4th is 1, so I to the 5th is just 1 times I, or I. I wonder if there's a pattern happening yet. Let's try I to the 6th. I to the 6th would be I to the 4th times I squared. And you can break those up any way you want, but this is probably easiest. I to the 4th is 1, and I squared is negative 1. So 1 times negative 1 is negative 1. Oh, I see something repeating. So here, I'll bet the next one's negative I. Let's see. I to the 7th would be I to the 4th times I squared times I. Sure enough, this is 1, this is negative 1, so that's negative 1 times I, or just negative I. So if you're a betting person, what do you think the next one would be? Negative 1, negative I, 1, I. Negative 1, negative I, I'm thinking 1. I to the 8th is I to the 4th times I to the 4th. I to the 4th is 1, and 1 times 1, sure enough, is just 1. The easiest way that I've found to deal with powers of complex numbers is to think of them in groups of 4. And so I to the 21st, if I was solving that, I could say, well, that's I to the 4th times I to the 4th times I to the 4th times I to the 4th. Is that enough i's yet? Oh no, times another one. So there's 5 of those times an I. But I to the 4th is just 1, so all of these really just sort of cancel out. So this would be 1 times 1 times 1 times 1 times 1 times I, which is just I. Okay, so that's a quick way of dealing with powers of complex numbers. So today we've talked about a definition of complex numbers. We've also talked about how you can add and subtract them, multiply and divide them. Okay, so take some time and do some of the homework questions. And if you have problems, contact your instructor.